Hello and welcome to part 8 of the revision lessons. The banging and crashing is still going on outside. It's summer holidays. I think they're destroying some stuff and throwing it into a skip. So hopefully it's not too distracting in the background and you can still hear what I'm saying, but fingers crossed. So, data storage this time, so mainly about databases and how they work and how we organise data online. So, here we go. Right. So we're going to talk about what databases are and what they're for. We're going to talk about database structure, so the different bits that make up a database so you can identify them. We're going to look at what relational databases are. We're going to have a look at the different data types that you can use in databases. We're going to look at what online databases are and where they might be used. We're going to look at database management systems, or DBMSs. We're going to look at structured query language, or SQL, and we're going to look at validation at the end. And when we've done all of that, we'll be done with data storage. So this one should be a bit quicker. Right, what are databases for? Basically, they're just used to manage a collection of data. So you have a whole load of information, you've got to get it organised somehow, and you use a database to do that. So it can store the information for you, and it will store it in a nice logical way. Because it's stored it in a logical way, it can also sort the information for you. So it can put it in order of alphabetical or numerical order, or however you want it to be done. And you can also use it to search for a specific term. So if you've got a big load of addresses, you can search for a specific person's name and it will come up. And that'll be part of how you use a database. So it's used to store, sort and search information. So database structure. Databases are made of tables. This is a very, very small database. It doesn't necessarily make an awful lot of sense, but it's got all the appropriate bits that we need. So, first of all, the whole thing itself that the data is in, it's stored in a table. So the table up there, the table is the whole lot. Then for every single column name that you've got, that's called a field. So for every single column is a field. So that's like all the information about one thing. So like the type of product that it is, or the item's name, or the price. And that will be a field. And then the title in the top of that column is the field name. So you've got table is the whole thing, the columns are the fields, and the name of the column is the field name. You then have records, which is all the information for one thing that's in your database. So in this case, product ID number 4 is an ice cream. It's a vanilla ice cream and it costs 90p. So that's a record for that particular product. So every time you have a record, it's a new row in your column, in your table. So columns are the fields, rows, magic again. Rows are the ones that go across. And if it helps you remember, if you row a boat, you row it across the river. You don't row it down the river, because if you sink, that's not good. So rowing goes across, okay? That might help you remember. And then the other thing we've got here is a primary key. Now, every database you have should really have a primary key. And the primary key is something that's going to have a unique value for each record. So in this case, it's a product ID, which is a good primary key to have. And then each ID will be different. You're not going to have a number, product ID number 6, or another product ID number 2, because otherwise it will kick up a fuss. And because it's unique, and it will never be repeated in the database, you can always find that particular record, or identify that particular record, by that column. Because because these, we've got quite a few that say sweets, and a couple that say ice creams, but we've not got any numbers that repeat. So these, you can always narrow it down to just one record by using its product ID, so it's a unique set. And the database uses that to, one, help organise itself and make sure it knows that each record is different, and 2, you might use that when you're linking it up with other tables and things like that, which we'll talk about a bit more in the future. So we've got the table is the whole thing, the columns are the fields, and the title of the column is the field name, and the record is the row, all the information about that particular product or person or whatever it might be, and that goes across, and the primary key is the one that's going to be specific and unique for each single person or each single product that's in your database. So, that's all you need to know for database structure. Right, relational databases. So, some databases need to have more than one table. If you're storing an awful lot of information about someone or something, it's a lot better to have it in separate tables to split up the different things. They've got some examples in here. So like you've got, what we've got here? We've got sales database. So it talks about the times that they're selling things, the products they're selling and the customers that they're selling. And then you go off to that and you might have one thing about the customer's details. So you might have the names of the customers here, but then you've got a separate different table that you have customer details in. So it could be if you're running a car dealership or something like that. You'll have one table that has all of the cars and the cars that you're selling. You might have one for the cars that you're selling, one for the cars that you're looking at buying from other people. You might have another table that's got all the customer information in, and then you can link the two together as you need to. But some databases need more than one table. They really are breaking things down. So, there will be a key to link the tables together. It can be the primary key. Sometimes you might have a different column that will have another key in it that you'll use to link the table, and that's called a foreign key, but you don't need to worry about those too much. But the good thing about having these in more than one table is that you're having to repeat things less. If you had two separate databases for all the people that are buying cars and all the people that are selling cars, you'd probably need to have the customer details in both, which means you're repeating stuff you don't need to repeat. Also, if you've only got a small table, you only need to fill in one at a time, which means you haven't got to search through a massive great table to find the bits you need. You just go to the table that you want, that's the customer details. You haven't got to look through all of the other information as well. And because of that, you're going to make less mistakes, and it's going to be more efficient. You're going to be able to fill that database in faster. You get the right form up, you put in the information into that particular table, job's done. So that's why we have relational databases, and that's what relational databases are. So they're a database with more than one table in them, and we use them because they're a bit more efficient and are an easier way to organise the data. Next. So, data types. I wanted to make this a bit bigger, but I couldn't quite fit it in there, so I've had to put it down the bottom. So, data types are all about when you're storing information, these are the different ways that the information can be stored, because the database needs to know what sort of information it is. So it could be that it's text, and text can be any character at all. So it can be letters, it can be numbers, it can be spaces, it can be symbols, anything like that can go down as text, and that's fine. You can also have a number one, which needs to be a numerical value. So it needs to be a proper number. So it could be 1.5, it could be 73.6, could be 9.4, could be 7, whatever it is, it's a number with a numerical value. Bear in mind, if you're looking at databases, telephone numbers don't count as numbers, because telephone numbers all start with a 0, and no normal number starts with a 0, so it kicks them out, doesn't like them. It just takes the 0 off. So, like, if you're going to have the institute's number, it would start off with 1206. And that makes no sense, because it should be 01206. You can also have integers. Integers are numerical values, but they have to be whole numbers. So it's got to be 7, 12, 92, minus 5. It can't be 3.2 or 7.5. It's got to be a whole number. Then you've also got dates and times, which are obviously just dates and times. So if you're using a date of birth or something like that, you use a date field rather than a number field. It makes a lot more sense, because numbers don't work the same as dates, because numbers go up in 10s and dates go up in 28s or 31s depending on the month, and it gets very complicated. So date and time, always good to have a separate thing for date and time. And then you have Boolean data type. So that's where it's just going to be yes or no, true or false. It could be male or female, but probably not, because they tend to have more than 2 options for that now. But so these are some examples. So we've got forename, surname, address. That's all going to be text. Date of birth would be a date or a time. Number of children they have would be a number, and that would probably, hopefully, be an integer because you shouldn't have 2.4 children, although that is the average. And then you've got, have they signed up to the mailing list, yes or no? So that would be a Boolean one. But yes or no, true or false, on or off, those kind of things. So if it's something that's only got 2 options, you can put it down as a Boolean. Any more than 2, Boolean doesn't work. But it just makes it a lot easier to search for all the people that are on a mailing list. Rather than searching the word yes, you just say, yeah, all the ones that are there, we'll have those. And those are your data types. So it's text, which can be any character, numbers, which can be numerical values and they can have decimal points in, integers, which are whole numbers, date and time, which are self-explanatory, and then the Booleans are just the ones with 2 options, yes or no, or true or false, or something like that. So those are our data types. Right, local and online databases. If you've got a database in your company, it's either going to be a local one or it's going to be an online one. And the same way that networks are either local or online, the same with a database. So if it's a local network, that means that it's stored on your network. And when I say your network, I mean the ones that are connected by cables in your building, or possibly Wi-Fi in your building. But all the things that are part of your network are not connected to the internet. So it's more secure when you do that, because obviously you can't have anybody hacking into you from the internet because you're not connected to the internet. So that's a good thing. It's also a faster access time than an online database because internet connections can be a bit slow, especially compared to your own office network. So that will slow your access down, your access time down if you're working online. But if you've got your own network, it will be a faster access time. And it's quite good for small businesses because obviously everything needs to be connected by a cable. So it helps if you're all in the same building. If you want to have a bigger business that uses a local network or a local database, then you need to pay out for having cables between your different parts of your business. And that could work out to be quite expensive depending on how far apart your businesses are. So that's one option, is the local database. The other option is an online one. So on this one, everything is held on an internet server somewhere. So you have a database server on the internet that you connect to over the internet. So the good thing about that is that anywhere you've got an internet connection, you can access it from. So you can get it from your mobile phone or your tablet, when you're out for a walk, if you're in the office, if you're at home, you should be able to get to it anywhere. You'll probably need to log into it in some way with usernames and passwords, and because it's out there on the internet, it is going to be less secure. Doesn't mean it's going to be not secure, but it'll be less secure than a private network. People that use this kind of thing, Argos use it. So they've got an online database. So whenever you go onto the Argos website and say, right, I want to buy something, you can check stock in the area, and it will just check its database and look at all the shops closest to you and probably tell you that it's all out of stock because what you want is what everybody else wants. Or is that just me? It happens to. But it will check it, it will go through the database, and it will tell you how many of each thing it's got in stock and where. And that works with all sorts of different shops. They have the same kind of idea. Also, search engines. Search engines use a massive online database of everything that's on their website is about, and that's what it uses when you type in your search terms into Google. So it will look at its database, it will say, well, where have I seen those words before? Where have people that have searched for those words gone to before? That kind of thing. And it will use that online database to give you your answer. So that is local and online databases. Right, data management systems, or DBMSs. Sounds really complicated. It's actually really easy. It's just the program that you use to make a database. So if you look on your computers at college, we have Microsoft Access, which we make databases with. Microsoft Access is a DBMS, or a database management service. So it is literally just the program that you use to make a database. It's not anywhere near as complicated as it sounds. And with that, you can make tables, because you need tables for your database. You can create fields, which obviously you need as well. You can add the records. It also lets you search for your database for specific things. It lets you sort your database. It also handles the security. So if you're going to start setting access rights on certain bits and setting passwords, it will deal with that for you as well. And it will let multiple people access the database at the same time. They might be working on different access levels, so some of them will be able to look at some bits, some of them won't be able to look at other bits. You can set that up yourself. But you can have more than one person working on a database at once. It's doable. You are allowed to do that, because whenever you add a new thing, a new record, it automatically saves it. It doesn't wait until you've added all the records and then click save. It does it for you straight away. Whenever you start a database, the first thing it asks you to do before you do anything at all, it says please save it, because then it just updates it all the time, which means that if someone else comes in on it, they'll have the latest version, and when they type something in and change it, it will immediately get saved and updated to your version as well. So that's a good thing. And that's what database management systems do. So create databases, make the tables, make the fields, let you search and sort, do the security, and let multiple people use the database at once. That's what they do. Right, structured query language, or SQL. Once again, it sounds terribly complicated, but not quite as bad as you think it is. It's just a language that's used so you can do things with your database. So if you want to add things to your database, if you want to search things in your database, you just write something in this language and it will then do that command. So you write something in the language, give it a task, it will then run that task. It could be things like a query, which is a word for search in databases. So if you query something, you're looking for a specific search criteria. It might be somebody born in a certain year, or somebody with a specific name, or somebody within a specific age group, or somebody above a certain height. It could be any of those things. But that will be a query, and you can write a query in SQL. It can also retrieve information for you, so it can get it off the database and bring it up. You can add things to the database with it. You can add records. You can update records as well, so you can change stuff and make sure it's up to date. You can delete stuff that you don't need anymore, or people that have left your company or your database. You can make new tables, and you can also set permissions. That says permissions, which is wrong. Obviously getting tired, I've done a lot of these videos recently. So it sets permissions for different people. So you can, if you've got maybe a multi-layer database, you'll have certain tables that people can't see and certain tables that people may be able to see, and you can set those permissions there. You can also set it so maybe people are allowed to look at a specific table but not make any changes. We talked about read access and read-write access and full control before. So you could set those permissions on a database as well to stop people from either making any changes at all, or they can make a change but they can't delete or add anything. Those kind of things. You can set those permissions depending on how much you trust that particular staff member or what their staff responsibilities are. And that's SQL, Structured Query Language. Right, last bit, another deleted hyperlink. Validation. So this is something that you can put into your database to make sure that when people are entering in new data, they don't make a big old mess of it. It's very easy when you've got a table in front of you to type the wrong thing into the wrong column. Very easily done, especially if you're not looking at the screen and you're just going through and you're using the tab button. You can push it too many times, or you can just click in the wrong bit, and then you end up not putting the right information in. So you can add validation to your database to help you with that. So the kind of things you can do is you can set the format, so it can check the format. So when we were talking about data types, it will, if you have a numeric value and you type somebody's name into it, it will say, this isn't a numeric value, this is text, that's not right, and it will come up with an error message. Same way if you did it, you had a Boolean thing and you had to tick a box to say yes or no, you were trying to type into it, it would come up with a problem. You can also have a range setting. So for instance, if you had a field in your database that was somebody's height, you can set a range that you're going to allow in, because somebody could easily type in the wrong height. If you put somebody in as -5 foot tall, that's not going to be right. So you could set a range that anything less than 1 foot tall, you're not going to count. And anything over 8 foot tall, you're not going to count. So if somebody tries to type in like 6.8 foot, or I don't know, maybe they're supposed to put in 1.85 meters, and they put in 18.5 meters instead, then it's going to come up with a range problem and it's going to resort that. And then the last one you can have is a presence check. And a presence check just means say there should be something in this box and there isn't. And that's a problem. So you've missed something out. So you could have that on all of your different tables maybe. So if you've got somebody's first name and last name, if it's not filled in, it will come up with an error. Probably if you've signed up for things on the internet, if you miss something out when you're doing it, if you've not got one of the ones that have got the asterisk next to them, you haven't filled in those boxes, and you miss one of them out, it'll go, oh no, you've got to fill this in, it's got an asterisk next to it, we told you have to fill those ones in, and that's doing a presence check to make sure there's something there. You might have some where you don't have to put things in, but there will be presence checks on the ones that you do, and that's how a presence check works. So you've got format validation, checking to make sure it's the right data type. You've got range to make sure it's not higher or lower. And you've got presence checks to make sure there's something there. And that is the lot for databases. And thing didn't click, so I'll try again. There we go. Yeah, that is the lot. So that's it for now, and we'll see you in the next video, which should be, I think, the last one for Unit 1. See you later.